Okay, so today we're going to talk about the law of sines. Um, the law of sines is 10.1. Um, in the world, every triangle is not a right triangle. Just think about in general. If you were to just look at anything that's triangulated in any shape or form, it's not always guaranteed that it's a right triangle. In right triangle trig, we can use SOHCAHTOA, we can use Pythagorean theorem, we can use all of those things. But because not all triangles follow that lovely right angle, sort of triangle, we need something else to do. So that's what this word here means. This word here, that oblique triangles, means a triangle that is not a right triangle, okay? So the first rule that you need to know is called the law of sines. And the law of sines basically says that if you have A, B, and C, then the thing to note is that large capital letters are going to be the angle measures. Lowercase letters are going to be across from the angle measure, and those are going to be lowercase. I want you to use that same ideal there. So I want angles to be uppercase letters or Greek letters, and then I want the lowercase to be the side measures. So this is an interesting fact, that the sine of angle A over little a will equal the sine of angle B over little b. So that's one fact. But you can also set both of those things equal to the sine of C over C. So kind of an interesting set of rules that we have. So in any triangle, now that actually includes your, a right triangle can follow the law of sines as well. Any triangle, if you know the side opposite an angle, then you can do the sine of that angle over its opposite side. And this ratio holds true for every set. It will be the same exact amount. So the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. And you can use any combination of the two. So let's say that I was dealing with A and C. I could use those. I could use B and C. I could use A and B. You can use any particular combination that's going to help you get what you want to get. Okay. So now that we have that rule written down, let's look at an example. Okay. It says solve the triangle. Now, anytime any of the instructions say to solve the triangle, what they want you to do is they want you to find any missing angles and sides. So whatever's missing, they want you to find it. Now, what's great is the 180 rule for triangles is true for any type of triangle. So this particular triangle, we know that angle N will be 180 minus 112 and 29. Now, sometimes people I've seen where they'll add 112 and 29 together. First, get that 141 and then subtract it from 180. That works. You can do that however you want to do that. So you could have also done that. But however you go about doing that, you get that it is 39 degrees. So let's put that in there. Now, let's talk about some next steps here. Some things to note, that the smallest angle should always be across from the smallest side. So this is, I'm going to make a little L, and I'm going to make it cursive L so that it looks like an L and not like a 1 or something. So the smallest angle, 29, is across from the smallest side. So we know that 22 should be the smallest measure we get. If it isn't the smallest measure we get, that's an indication that we entered something wrong into our calculator, did something funky, okay? So let's set up the law of sines. Now you always have to start with a pair that you have finished. So we have angle L, we have side L. So we're always going to start with a pair that is finished. So we know that the sine of L over L is equal to the sine of, let's just go with M over M. Now, again, I said you had to start with a pair that's finished. This pair is finished, meaning I know the angle and its opposite side. So now let's plug in what we know. So I know that the sine of 29 degrees over 22 is the sine of 112 over little m. Okay. Now, the sine of 29 and the sine of 112 are something you're just going to have to put into a calculator. These do not rely most of the time on a unit circle kind of value, so expect that you're going to have to use a calculator for this section. And the indication here is it says round to. Anytime it's going to round to something, most of the time that means you're going to enter it to the calculator. Let's follow that rule of thumb. Let's make the sides to the nearest tenth and the angles to the nearest degree. Okay. So if we put the sine of 29 into a calculator, make sure it's in degree mode. That's going to be 0.4848 over 22. And the sine of 112 is 0.9272 over m. So all I've done is taken those values, put them into a calculator, and then think about how we can solve a proportion like this. One great thing about a proportion is that we can cross multiply. So let's go ahead and do that. So if we cross multiply, we get 0.4848 m equals 22 times 0.9272. Now I'm just going to wait to put that 0.9272 into a calculator. Please take your original measurements out like 4 decimal places, and don't round to the nearest tenth or the nearest whole, whatever we're finding, until you get to the very end, because the end part is where you want to be, to the nearest tenth. So let's think about that calculation. How could I get that m by itself? What would we do? We got to divide, right? So our m is going to be 22 times 0.9272 divided by 0.4848. Okay, so let's actually do that calculation. So 22 times 0.9272 divided by 0.4848 is, to the nearest tenth, m is 42.1. Now they didn't give us any kind of like length, you know, inches, feet, whatever, so just leave it. That's fine. Okay, so now we have found m, and unfortunately this is not a right triangle, so we can't use the Pythagorean theorem, so we're stuck doing it again. So we're going to do it again. Now use the same information you already did. Use the same information as before. Let's do the sine of L just over L, but this time let's do the sine of N over N. Yes?
If it's any easier, can we just keep like sine of 29 and just put sine of 29 close to parentheses times m?
Definitely. So if you don't want to put the, you know, that decimal, that 0.4848, and just put it into the calculator as the sine of 29 and use that, for sure. And let's do the next one kind of, let's write it like that.
On paper, can't we keep it set up as sine until we get to the last step?
Exactly. So let's do that. Let's do that for this next one. Okay. So we get that the sine of 29 over 22 equals the sine of n, which we found to be 39 degrees, over little m. So we're going to do the suggestion that was made. Let's just keep that there, and then we'll enter it into the calculator at the very end. Okay. And then we don't have to worry about rounding. That's a good thing about that. Okay, so n is going to cross over and multiply by the sine of 29. I'm just going to put it in parentheses so that, and then we're going to get 22 is going to multiply by the sine of 39. So what's the thing we have to divide off? What's the thing?
Sine of 29.
Yeah, exactly. We got to divide that sine off. So if we leave it in that sine notation, nothing wrong with that. It's actually probably a little more precise. It would be 22 times the sine of 39. There is a parenthesis on the calculator that you will have to close that parenthesis around the 39. And then the same thing when you divide by the sine of 29, close that parenthesis around that. And then rounding to the nearest tenth, we get that n is 28.6. Now let's just do a little check. Let's just do a little quick check. Our smallest angle 29 was across from the smallest side 22. Our medium angle 39 is across from the medium side 28.6. And our largest angle 112 is across from our largest side 42.1. It's not a bad idea to just always make that quick little check, because if those relationships hold, you probably did it right. Okay. Does anybody have any questions about how we apply the law of sines? I like the law of sines. Law of cosines is a little funkier when we get to 10.2, but for 10.1, it is a straightforward sort of formula, and those proportions are solved pretty nicely. Okay, everybody good with that example? Okay, let's do another one. Here's a little more of an application. I'm going to write these in a little bit bigger for you here, but you can zoom in if you want. It says that's 62, that's 49. We're going to call that y, we're going to call that x. So this is angle x, angle y, and angle z, and then little z here is 650. And it's 650 feet. Okay, let me read you the problem. It says the angle of elevation from the top of a building to a hot air balloon is 62 degrees. So somebody is at the top of the building, they look up to the balloon, and they have to raise their head 62 degrees in order to look up at the balloon. Now, directly across the way is a building at the same height, but they are 650 feet apart. If a person standing on the roof of that building looks up, they have to raise their head 49 degrees. That's their angle of elevation. It says find the distance from the hot air balloon to each of the buildings. So we're going to find little x and little y. Now, you might notice that if we do the 180 rule, and if we find angle z, if you subtract 62 and 49 from 180, you get this angle measure here is 69 degrees, which tells us it's not a right triangle. So it's always a good rule of thumb. Do I have a right triangle? If you have a right triangle, you can use Pythagorean, SOHCAHTOA, and the 180 rule. We do not have a right triangle, so the only rule we know so far that applies to every triangle is the law of sines. So let's think about what pair we know. We know the z pair. We know for sure that big Z is 69 degrees, little z is 650 feet. So that's what we always start with. So we're going to do the sine of z over z. And let's just start with x, I don't know. And it's going to be the sine of x over x. So let's go ahead and let's plop the stuff into our formula. So we have the sine of 69 degrees over 650 feet is the sine of 49 degrees over x. So you'll see I use this pair. You have to use one finished pair. And then I used this pair to find the missing information. If we cross multiply, we get x times the sine of 69 degrees equals 650 times the sine of 49 degrees. Now let's go ahead and before we actually enter this into a calculator, let's contemplate what we know. 650 should be the longest length of everything we do. It is across from the biggest angle. Now, the one that's across from 62 and the one that's across from 69 should be very close, I would say. They're not going to be so super far apart. But 650 should be the longest length. Okay. So what are we going to enter into our calculator? We're going to enter that x is 650 times the sine of 49 over the sine of 69. And we get 525. Let's go to the nearest tenth again. 0.5 feet. Now it makes sense that it should be less than 650, not a super big amount. So there we go. There we got x. Okay. Any questions on how we got our first missing value? I'm sorry, I'm not getting it to do anything good today. I killed my x slightly. That's okay. Okay, so now we have x. We don't have little y. So we're going to set it up again. Use the same thing, the sine of z over z, but this time we're going to do the sine of y over y. So we know the sine of z over z. That's the sine of 69 degrees over 650 equals the sine of y which was 62 degrees over little y. So that's going to be our setup to find little y. Now let's go ahead and cross multiply. Let's go ahead and cross multiply. We get the sine of 69 degrees times y equals 650 times the sine of 62. So remember, whatever's touching that y is multiplication. To get rid of it, we're going to divide. So it's going to be 650 times the sine of 62 over the sine of 69. Let me tell you what that is. We get that y is 614.7 feet. And that's really, look how close 62 is from 69, and that's pretty close to that 650, but less, okay? So let's go over what we found. We found x is our smallest side, 525. It was across from 49. These two are pretty close. Their values were pretty close, 614.7 and 650. So that is how you apply the law of sines to more of like a word problem, okay? Be careful. Don't jump to SOHCAHTOA or Pythagorean unless it's a right triangle. And these ones will not be right triangles. Any questions about that example? Okay. So then there's some problems here. There's not a lot of them. I want you to do them now. Okay, work on them for the rest of class. Tomorrow we're going to look at what's called the law of cosines, which is going to help us find out even more information about triangles that are not necessarily right triangles. So that's it. Do your thing. And if you need me, just ask.